Hello, my name is Christopher Lin, and today I will be presenting a review of the entire Unit 10 on solutions. So let's get started. Our first slide will be on the most important molecule on Earth, which means without it, we would probably not exist. People encounter it in everyday life, and as you can see from the title, the molecule is water. Water has many unique properties that can do things that we never think about. The first thing is that water is liquid at room temperature, tending to be around 70 degrees Fahrenheit. It is made up of 3 atoms, 2 being hydrogen, 1 being oxygen. The oxygen has 6 valence electrons, and the hydrogen has 1 valence electron each. Since they are both nonmetals, they form a covalent bond. Oxygen, however, has a stronger pull to the electrons than hydrogen because of their huge size difference. The oxygen becomes slightly negatively charged when it takes the hydrogen's electrons, while the hydrogen becomes positively charged when it loses them. This makes H2O, and it is a polar molecule since it is a molecule with a slightly positive end and a slightly negative end. These charges help it form strong hydrogen bonds with other water molecules to make bigger masses of H2O, hence a glass of water or something like a puddle. Water, H2O, is called the universal solvent partly because it is polar. This just means that almost all solutes can be dissolved into it, making it a more flexible solvent than any others. This will be important to know. One of the more interesting traits of water, in my opinion, is that it expands instead of contracting when it freezes. This is unique only to water since it shares this with only 4 other elements, but no other molecules, which are silicon, bismuth, antimony, and germanium. Water also has a high specific heat, which means that a lot of heat has to be added to it for the temperature to increase by 1 degree. This is the reason why on a hot summer day, people aren't getting boiled alive in their backyards. The water is not absorbing all of the heat that is hitting it by the sun. It stays cool to help us out. The last thing that you need to know about water is its surface tension. Surface tension allows things like certain insects and leaves to float on its surface. Not enough force is applied from them to break through the water membrane, allowing them to be on top and not sink. The next thing we'll talk about are mixtures and pure substances. Mixtures are basically a group of anything mixed together that can be physically separated. They are heterogeneous and can be represented by salad, Chex Mix, salt water, etc. Pure substances are a group of anything that are mixed together that cannot be physically separated, which means using chemical reactions on some are able to separate them again. They are homogeneous and can be represented by diamonds, water, salt, etc. Also, an important fact to know is that all elements are pure substances. This slide is about solutions and what they are made from. Solutions are homogeneous mixtures of 2 or more substances that tend to be made from a solvent and a solute. Solutes are what are being dissolved uniformly into a solvent, which does the dissolving. How well a solute dissolves into a solvent is called solubility, which will be shown in the next slide. Solubility follows just one rule when determining whether it is soluble. Like dissolves like shows us that rule. This is a term many chemists use to say that polar solvents dissolve polar solutes. Non-polar solvents dissolve non-polar solutes, and polar solvents do not dissolve non-polar solutes, and vice versa. For example, in the picture, a diagram of ethanol and water is shown. They are both polar, so they are able to mix together. You can also speed up the rate of the dissolving by doing certain things, like stirring the solution, heating it up, or crushing it into smaller particle sizes, if the solution allows you to, with, like salt and water. This next slide will talk about how stuff dissolves. First of all, we know that there is always a solute and a solvent in these mixtures. There are two different kinds of compounds, one being an ionic compound, while the other is a covalent compound. The ionic compound can be represented by salt, NaCl, dissolving in water. In the picture, salt is represented by NaCl. Na, which is also known as sodium, is shown in purple, and Cl, which is also known as chloride, is shown in green. The reason that this is an ionic compound dissolving is because the sodium and chloride break apart and both get added to the solution, resulting in two particles getting added. When it is placed in the H2O, the sodium and chloride break apart and spread through the dissolvent like this. Now here is the structure of a sugar molecule. Unlike salt, when sugar is placed into water, they just break up from a group of molecules into individual molecules like this. Their elements don't individually break off. In the 7th slide, we shall talk about the mole. This should be a review for most of the students in this class. A mole is a given number of particles used to measure very small things in chemistry. It is represented by Avogadro's number, which is 6.02 times 10 to the power of 23. The diagram on the right shows the triangular relationship of mass, molecules, and moles. It presents that mass, particles, and volume can easily be converted to moles or even to mass, particles, or volume through moles, which means it's kind of like a highway. You can go any which way you want without running into trouble. So then it is important to know what is on the last bullet point as well. Molar mass equals X grams divide mole. You can switch it around using your algebraic skills for your own comfort. The concentration of very dilute solutions, parts per million, also known as ppm, is an important subject to learn about. ppm is used by the EPA to figure out how high certain toxic substances can be added to food and clothing without harming us. Parts per million can be looked at by mass or by volume. With mass, this is the formula. And for volume, of course, this is the formula. These will be useful to know in the future. Molarity is another way to describe the concentration of a solution. It is the number of moles of solute per liter of solution, or the less wordy version, just moles of solute divide liters of solution. Colligative properties have properties of a solution that depends on the amount of dissolved solute particles in the solution, do not depend on the type of chemical species present. There are two kinds mainly of colligative properties, mostly freezing point and boiling point, but in word problems you will see them as freezing point depression and boiling point elevation. They are represented by these formulas to become solved, so it would be wise to memorize them. And that was my presentation. Thanks for watching.